All right, the fifth lecture, action perception couplings. Now, to look a little bit at where we have been so far and where we're going, we have been discussing external computation and representation in the first few lectures, which was most closely related to what we know of traditional ideas of knowledge representation and also computer science and computer representations. But then taking the idea of thinking and cognition outside of the brain alone and putting it also partly outside in the world in the form of distributed knowledge and distributed cognitive processes. After that, we have been looking at how all of this is not just an individual thinking activity, distributed, but still individual. No, we are strongly situated in practices that is something to do with how human beings interact socially with one another and how we build up communities of practice and culture, and how all our dealings with artifacts and the representations we create are sort of riding piggyback on the social practices that are already there and are further sustaining and transforming and enhancing those practices. So we can never understand what external representations are really doing unless we also understand how we are socially situated. We've been looking at a few aspects of what that means to be socially situated. Now, as I said last time in closing, we haven't been really talking about the body proper, right? The thing we normally associate with the body, which is your arms and legs and head and your belly and your feet and so on. So we're going to talk a little bit more about that today when we're going to talk about what I sometimes call action perception coupling. So the linkage of doing stuff and perceiving stuff. You can also say sensory motor coupling, which is a bit more technical and a bit more a level down, so to speak, in the hierarchy. So sensors, motors. It also has a little bit more connotations with robots, right? So robots, in robot literature, you usually talk about sensory motor coupling because you talk about sensors and motors, right? And then after that, we have one more lecture that is not on this screen, which is about participatory sense making. And participatory sense making is, if you wish, sort of a mixture of social stuff. So it's between people, but it's very much focused on the things we're going to talk about today, the sensory motor or action perception coupling. So it's participatory sense making lecture will be about how we with our bodies in the immediate moment of interacting with other people, how we sort of attune and couple to each other in interaction, right? So think about it. Maybe the best metaphor would be like an improvised or a dance, two people dancing together, ballroom dancing. You have to constantly respond to each other, right? That's the kind of stuff that goes on in participatory sense making. And then after that, we have the last lecture, which is about phenomenology, which is the philosophy that to a large extent underlies all of this. But it's a particular kind of philosophy. You could look at many of the things that I've been talking about so far without adhering to phenomenology as your main basic philosophy to go by. You could also say I'm a scientific materialist realist, and still I'm buying into a lot of the embodied cognition stuff. You could also say I'm going even beyond phenomenology. I'm a post-phenomenologist, as for example Peter Paul Verbeek is, who is of the University of Twente. But nonetheless, I think it's very informative to at least have a look at phenomenology because it's not something that you usually get introduced to in human-computer interaction courses. And at the same time, it has had a significant influence on human-computer interaction. There have been several people in the past already talking about phenomenology. So it's good to take notice of this, at least as an introduction. But today, the body. Now, actually, I'm going to disappoint you even more. So I'm not going to really talk about the biological body in all kinds of details. I'm not going to give you any medical knowledge on, and I'm not a biologist. I'm not a doctor, a medical doctor. So it's not going to be about blood streams, nervous systems, and so on. I'm going to talk about the body in a very, very abstract way, in some sense. If you consider this body here abstractly represented as a circle, one of the main starting points that we have to realize is to see the body not as a purely physical object that is just there, like a stone or a piece of wood lying around, um, or a machine, like a robot. The living body that we are, and animals are as well, and also even bacteria or maybe even viruses, but let's not go too far. Let's just talk about ourselves for the moment. Human bodies are much more process than thing to begin with. So human bodies are active processes. And what these processes do, so we are constantly, I mean, there is this way in which we think of ourselves as not doing anything, right? If I just sit still like this, I think, well, I'm not active right now, right? But of course that's nonsense. Our body is full of activity constantly, right? There's all kinds of stuff going on the inside, and it never stops, right? So we are process first, but this process generates a certain structure that you can take away or sort of distinguish from the background environment at some point. So we are not just wind blowing through the leaves. We are a process that sort of creates a whole. And Maturana and Varela call this the boundary. A membrane, right? And they talk about the living cell, the biological cell, as the main unit that they focus on. And they talk about how this cell is constantly sort of regenerating itself and it's sustaining itself, it's keeping itself intact in response to all kinds of perturbations from the environment. So the environment is constantly trying to break us down, but our processes on the inside generate a boundary that keep ourselves intact. So the interesting thing is that the process that keeps us alive is also the process that produces ourselves as an object, as a thing that is apart from the rest of the world and that creates a boundary between us and the world in the first place. It's the same kind of process. There's not first already a human being and then the human being starts acting and doing stuff and thinking about, oh, what should I do to stay alive? No, all of that is part of one and the same integrated process. It's the process of staying alive and being there, being in the first place. So the fact that we are a something that is not another thing, the fact that we are not the apple or the coffee cup or the tree out there, but we are an individual human being, that's the same kind of process that generates that keeps us alive. And according to Varela and Thompson and Rush and also Randall Beer, that's also the same process that underlies everything that has to do subsequently with behavior and also intelligent behavior and intelligence and cognition. So when we look upon the world and we perceive the environment, we are still in some sense always in the process of keeping ourselves alive and intact. Once you start with that basic process of a system that tries to keep itself intact, right, that doesn't want to disintegrate or fall apart, the next step is to see that the behavior that we generate in order to respond to the environment is an emerges from the interaction between ourselves and the environment. So it's not something that is internally planned by a brain and then executed like a software program, first planning and then say telling the body to move and behave in a certain way. No, there's an ongoing interaction with the environment, and this ongoing interaction first already creates ourselves, it creates the boundary between ourselves and the outside world, but then it keeps on interacting and interacting, and then at some point our whole body as an integrated unit starts to respond to the world, but it's still part of the same ongoing coupling to the world outside. Well, through those interactions, at some point you generate what are called couplings. And a coupling means that there is some kind of stable relation between yourself and the outside world. And in everyday language, we could call this like a skill, a habit, a routine, um, a f- like some kind of behavior that is stable and is sustained over time. For instance, walking, or um, if you play table tennis, the way you at some point get into a kind of uh, uh, flow of tick-tock to the ball, right? The skill. Now, these couplings, they involve a certain relation between how we at any moment in time see the world, so what we see or perceive in more general, not only with our eyes, but also with our ears and with our entire body, with all the sensory systems that we have. We respond to the world, so the world has an effect on our sensory system on the one hand, and on the other hand, we have an effect on the world because we act, right? So I take a step forward, I move my head, I move my eyes. Even movement of your eyes is an action already, and it changes immediately the input that I get from the world, right? So if I move my head or if I move my eyes, at the same moment, the flux of visual data on my retina changes immediately. And what brains learn to coordinate is not to necessarily make pictures of the outside world, but what they learn is to detect the patterns in the stable patterns, or the constant patterns between the constants between if I move my head, everything changes, but something also there's some kind of regularity in that, right? And I only catch the regularities by moving, by acting. So in order to see the world in such a way that I can act on it, I actually have to first move, right? So this is a very important point. We tend to think about perception and action as something that goes in a certain order, namely, you sit still, you do nothing, the outside world shines on your eyes, it tells you, oh, here is something for you to see. Then your internal brain starts to process that. It's like, oh, what information did just arrive in our eyes? Like there's this little guy in your head reading off the data. Oh, what just came in? Oh, there's a picture of a lion. Hmm. Match it to some tables, and this whole computer metaphor thing is deeply ingrained in how we think about this, right? So we think, oh, there's the brain is internally sort of processing, then matching the incoming data to a model, and so, oh, this is the model lion. Oh, what should you do when you see a lion? Now, then you start to look in the table, possible actions: run away, sit still, freeze, whatever, and then you do something, right? You give the order to your body to respond. That's not how it goes at all. It's the other way around. In order to see anything, we already need to move. We need to be moving, because the things that we see are not just out there waiting for us, and just shining their light on us or something. The things we see are the regularities the patterns that emerge when we move, and the flow of information in our eyes is constantly changing with our own movements. And then at some point we detect what are the sort of the stable patterns in that, right? So you look at things from all kinds of different angles, and then this thing becomes a sort of stable pattern in the middle. And then you start to say, oh, this is what I'm seeing. That's how perception works. Right? So there's a primacy of action. It's not the passive reception of information. Touch is not an experimenter's push on the skin, but an observer who actively explores the surfaces of objects. Right? I'm exploring, I'm probing, I'm going out in the world and getting the data that I need in order to make sense of the world. Now, if you look at the physical body, there's already interesting aspects of our bodies that give us sort of information for free. So, for example, our our bodies are created in such a way that most of the things that we use to sense and sample the environment with, our eyes, ears to some extent, our hands for grabbing and touching and feeling, they are at the front of, and also our mouth to make sounds. Most of the stuff we act with and we sense with is on the same side of our body, right? There's only relatively little, there's almost nothing on the back. So this means that we have a front and a back, right? You could make a robot that is a perfect circle with sensors on all sides. That kind of robot would not have a front and a back. For that kind of robot, it would suddenly be a problem to think about, hey, where am I looking? What is my orientation? And what side of the room am I currently facing? And so on. For us, that's much more easy because the space around us is sort of for free. We don't have to do anything for it. It's already divided in everything in front of me and everything behind me. So we use our own bodies and the physical structure of our own bodies to immediately make categories in the kinds of stuff that we perceive. It came from the back, it came from the side. There's a left to us, there's a right to us, there's symmetry. So there's all these kinds of patterns that actually stem from the physical structure of our own bodies, because we're not some kind of formless blob or circle, right? And a nice example also that Andy Clark uses is that of the way that gibbons move, and we do sort of the same thing. So he also explains that when we walk, you would think that you need a lot of computing power to actually sort of instruct the legs to move in a walking pattern, right? And of course, it's too simplistic to say that nothing of that is true, but it is to some extent the case that actually walking is in a way just pushing your body forward and then preventing yourself from completely falling on your flat on your face. So what do? You let one leg sort of go from the floor, and you let gravity just let gravity help you to just swing the leg forward, and then it hits the floor, and then it gives you a rest, and then you have to move your momentum over that hurdle, and then you let yourself fall again, and then you swing your leg again, which just goes by almost by itself by gravity again. And then once you get into that pattern, there's nothing much that the brain needs to do in order to keep that in place, right? The brain is not literally generating the walking pattern. What the brain is doing is making sure that you keep your balance, for example, which is a very different task. And you see here that gibbons do the same when they swing through the branches, right? In a nice way that they can do. And there's people having that made robots, brachiator, that actually work on the same way. So this robot hardly has any computer process. There's no computer process in this robot, the brachiator, that is really programming this. There's no software program that sort of describes the movement. It's just gravity, momentum, the mechanics of it, And the only thing is you have to give it a push, and then it needs to grab and hold and grab the next thing at the right moment. So there's some timing involved, but other than that, the whole system is just the mechanics of it is doing most of the behavior, right? So a lot of our behaviors and a lot of the way in which we perceive the environment is directly influenced by the physical mechanics of our body, and we use the constraints of our own body as information, right? Now, if we look at the interior of the body, and also still at a very abstract level, there's been some great work at some point in the 1990s and much more later on that I won't go into, also because I'm not the expert at all. But internally, you could say our body is maintaining all kinds of bodily states that say something about whether our body is, as a biological living organism, is doing fine or not, right? So at some point there's not enough food in our stomach. So all kinds of sensors start raising the alarm bells, like not enough food, not enough food, right? Or maybe you have a wound and blood is leaking out and energy is flowing away, right? So the membrane, the boundary between you and the world is broken. Now you have to fix that, right? So processes have to get working in place to fix that again. Or maybe your temperature is not good, right? You have to maintain a certain temperature in order, and that's important for all kinds of other processes to work. You have the hormones, so you have all these kinds of internal, what they call homeostatic processes that make sure that your body's integrity is maintained. Now, a lot of neural processing, actually the core of it, is all focused on that. And there's a lot of brain processes actually working on maintaining the internal bodily state. And you could say that's the oldest part of the brain, right? That's what first there was. There was not first an agent that was out in the world perceiving, acting, looking with their eyes and grabbing with their hands. No, first there was this internal system that was this internal machinery, right? Keeping the whole thing alive. Now, from that internal system, there's constant signals going into the higher level brain areas that are more involved in perception and action, like the cortical areas, this outer cauliflower structure that you always see in the pictures of our brain. And what is that doing? Now, what it's doing, according to Antonio Damasio, is that it's marking all the information that we get from outside in the world with a kind of value or valence that comes from the inside, saying that whatever I'm looking at right now, I want to know, is it good for me or is it not good for me? Is it doing anything for me or not? So we don't perceive objectively features of the environment as they are. Everything we see and the way we see it already is sort of colored by the value it has for us. But this is also context dependent. So when your stomach is empty, you start to see things in a different way. And a nice example of that I found always in the movie Madagascar, where there's a lion that comes from I don't know, remember, is he Leo? I don't know, remember his name. But the lion is friends with the zebra because they come from the zoo and they get food every day. So there's no reason anymore for the lion to eat the zebra, right? But then at some point they are on this island and the lion has not eaten meat for days and days and days. And then at some point the lion starts to see every animal around it as a walking steak, right? Now this is a very explicit comical representation of what is happening when your internal bodily state is constantly tagging the incoming perceptual information with value. Yeah, as long as you have enough food, you can see another animal as a friend. But at some point, your internal body starts to say, steak, 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 right? And you see moving objects suddenly as potential food. Now, this happens all the time. So when you see a coffee cup, it's not an objective physical object in the world. It's something for you. And this is because the way you see the cup, the way the information goes into your eyes and through your cortex out into the world again in action, in this sensory motor flow, this is tagged by internal information that tells you something about what the cup means to you in this current state of the body that you are, all relating back to the question in the end of, does this cup help me maintain myself, or is it a threat? Is it useful for me to be myself and stay who I am, or is it going against it, and should I take action to solve the problem? Now, in the end, all this whole bodily, internal bodily meaning giving has also been translated in theories about language. So what Lakoff and Johnson show, who talked a lot about embodiment of language, is that all our language and almost all of the words in our language, in the end, can be related back to things having to do with the body, right? So when I say I rate this higher than the other thing, that has to do something with literally being taller or somebody being higher up and so on. So there's all these metaphors relating back to bodily actions, but I won't go into it for now. But it's an interesting topic, and you could maybe use that if you're writing papers for this course. So do we really design interaction for sensory motor couplings? That's a question that you could ask yourself, right? We design wearable smartwatches, but are they really sort of helping us maintain this interaction flow of perceiving and acting? Or are they just physical things attached to the poles of our arm and not doing much, right? If you compare the watch with traditional tools that you use as a, I don't know, as a carpenter, for example, I would say that traditional tools are much better in becoming productive elements in this ongoing loop between doing and seeing, doing and seeing. The smartwatch, not so much.